Well, hi, good morning. Thanks so much for joining me in my shop. I'm going to be getting right back to that big old radio momentarily, but yesterday afternoon I worked on these two little radios, and I'm finishing a clock test with my cat's help. 8:47 on this clock. These ran all night. This one looks like 8:46, I would say. And the actual time is, can you see it up there? 8:46. Bingo. So both clock radios are keeping time. So I posted a short video about just cleaning up these two clocks and making them look a little nicer. So thanks, Shadow, for the help. Now we'll get back to the big old radio. Okay, back to this big radio here compared to those other little guys. So I managed to change one capacitor in the last video. I'm going to do the rest of them on this board, and then we're going to check out and see if the radio still works. Right, Shadow? Shadow. Shadow's not like Peanut. She's not quite so responsive. How are you? No, that would be your answer. So just before I get going here, a couple things. One is I've ordered two new tubes for this radio, one to replace the weak tube here, and the other to replace the EM84 tube, which isn't glowing at all anymore. And that's great. I really, most of the people I do work for, when I suggest things, they say, by all means, go ahead. I did have one case that went the other way, where everything I suggested, the owner of the radio argued with me. I began to realize he just really wasn't interested in getting his radio fixed. I don't really understand it at all. In the end, he just disappeared off the radar and abandoned his radio with me. This is a couple of years ago now, and there's his radio sitting there. Still needs a bit of work. Man alive. He just disappeared. That's the only customer that's ever happened to. So, oh well. Not so with this one though. Okay, so I'm going to carry on and get these capacitors installed from there. And we're going to test that radio. Well, sometimes this work can take me right to the edge of what I can tolerate without losing my cool. And certainly putting in those 4 capacitors did that. Boy, oh boy, very, very difficult, especially this bottom one down here. But I've got them in. I've examined the soldering. It looks good. I replaced the resistor. I reinstalled the resistor I popped out by accident. What's left is 2 more capacitors over here, which are easy peasy in comparison. But I gotta go and calm myself down a little bit, get the adrenaline out of me before I continue. I'll replace the adrenaline with coffee. Turns out replacing adrenaline with coffee is not really the best idea, so I'm going to try something else. I'm going to try swans. What are you doing?
I just slid onto the ice and I knew I wouldn't be able to get back on.
Well, the swans did it for me. That's all I needed. Nothing like a bit of swan every morning. Okay, now I'm going to pop the tubes back in. We're going to turn this guy on. I'm going to cross my fingers and hope it still works. Looks good though. Looks like I got it all soldered up correctly. There's no solder bridges. I had one capacitor push the solder pad off the board, but that's okay. I was still able to solder it in. So let's see what's happened here. I was just about to put the two output tubes in, and I thought, well, maybe I should show this on camera. Can you see how darkened the board is around these two tubes? Kind of dark over in this area too. It's not darkened around these. These guys aren't anywhere near as hot. This guy's not as hot. It's just these two output tubes, which look at that. What that means is all the components in this area have been running a little hotter than expected. You see a capacitor right here, and one of the old guys right there. So you'd be suspicious of everything in this area. But it just shows you how hot these tubes run. They run really hot. They burn you hot. Never touch these guys when they're heated up. Take the skin right off you. Okay, very close now. Okay, all ready to test it out here. Now I'm done this work on a radio with a very weak tube in it. It's not the best way to do it, but that's all I can do for now. So let's just hope everything's good. I've got the Magic Eye tube, the EM84 out. If you look at the screen of it, you can see it's darkened quite a bit. So I think what's happened is the phosphorus has been worn out on this. I'm not sure though. Could be the cathode gone in here. Okay, speakers connected. Power coming through the dim lights. Switch is off. That's pretty good so far. Here we go. Switching on for broadcast. Okay, the button didn't hold down, but the mechanics have worked inside. Turn up a little bit. No lights anymore. Wasn't there one light going before? Now there's no lights. Come on, baby. Make some sound. Bit of a hum in the speakers. Turn it up full. It's probably running with a very low voltage right now. Let's see what it is. 83 volts. That's a little low. Give it some time to heat everything up. Check and see, did I leave any tubes out? No. Boy, oh boy, that's quiet. This is nerve-wracking. Okay. What else could it be? Oh. It's coming. Okay, let's give it the full voltage here. Balance seems to work better. Okay, that's AM band. I've put the string back on. Oh, the light just came on. Thumbs up. Doesn't want to do much there, does it? What about if I do this? Okay, so the AM radio is working. That's good. We don't expect anything else to happen here because all I did was affect the... No, we don't have an FM antenna. On here. What's all the clicking? Kind of a hit and miss thing there. Really hard to spot the pointer. There it is. We want it over here. Well, no antenna. Need an antenna. Got an antenna right here. Okay, I'm gonna plug it in. This is a terrible situation here, but it's what I got. Need some talk. It's trying, that's for sure. Let's get that talk on here. Regardless of the distortion, what I want to check is the tone controls. Trouble?
His new stop-motion film on the book series, The Shaman's Apprentice, is available to stream now on CBC.
Bass doesn't seem to make any difference, but it could be the small speakers I'm using. And it's just the guy's voice. That made a difference. Bass button. There's no stereo on FM. Presence. Made a difference. Oh, I can't have music like that. Uh-oh, might get a copyright hit from that. Okay, I'm good for brilliance. Yeah, okay. Well, it seems to be working. Seems I got away with changing all those capacitors. Fantastic. Now, I got a bunch more to do. But nowhere near as difficult as those last ones on the board there. Fantastic. I will carry on. I think I'd be smart to take a couple of minutes here and just plan this out before I start digging into all these capacitors. So it's all the those brownish guys, these guys here. So just in this view, you can see quite a few of them. Most of them are fairly easy to get to. But there's one tucked up in there. Would have been easier had I done that before sticking these capacitors in, but what's done is done. So you have that one. Probably the rest of these are fairly straightforward to do. Got any other sneaky ones hidden? I thought we did. Maybe not. Looks like they're all clustered down here. And what I'm guessing you could call the audio section, but there may be more going on in here than just audio. Yeah. And we do have these two here, but I'm not too anxious to do them just yet. So, order of operation here, we're going to start with the tough guy back there. And then just basically work my way forward, I think. And how many is that? 1, 2, 3, 4, 5, 6, 7, 8. 8 capacitors. Okay, 9. There's one hidden under that wire there. 9 capacitors, something like that anyway. Okay. It's going to take a little while, but hopefully I can get them all done. Whoa, rocky seas here. Just throw the camera down. So the question would be, how do you possibly do this kind of thing? The capacitor I'm after is right here. Right there, just see it right down there. And on the other side, I have to find where it's soldered in. Somewhere there. Somewhere there under all these wires and here and there. So how do I do it? So first I make a general location, which I've already done more or less. But Tube sockets are good things to identify, edge of the board, stuff like that. So we see the capacitor is basically in line with this tube socket, and there's a board edge right up in here, which you can't see in the camera because I'm ducking down. Just like that. So there's an edge to the board right there, and then I can see something. Can't see much. So what I see are two little pieces of metal pins coming through like this. It's probably a terminal sticking out the other side. Nothing attached to them, so they've just pushed a terminal through the board there. So there's two little pins, and then the next thing is the capacitor, and you get the corner of the board right here, just above that tube socket. Now, where's the tube socket? Yeah, it's in there somewhere. Probably down in here. That puts the capacitor in this area here. So we're starting at the edge of the board. Sure enough, there's a terminal right there. So it's got to be the next soldered thing. Right up there. So that's probably one lead, and then the other lead is going to be straight from there. Wow, it wouldn't be all the way down to here, would it? That's too long, isn't it? So I can kind of see the edge of the capacitor right here. Is that really what I'm seeing? Yeah, it's fairly long. Okay. So gotta be that terminal, and gotta be this terminal behind the yellow wire here. So it's basically find your landmarks, work your way across. A little like I was gonna say it's a little like orienteering through the countryside. Okay, so I can get at that one, I can get at that one. Just have to pop the capacitor out and pop in the new one. Oh, it sounds so easy. Might as well keep showing you what's involved in this. So I've got a hook here, hook-shaped tool. I want to hook the capacitor. The end I'm going to unsolder. So I got to get it under there. Okay, so I've hooked it. And I need to. You can't be pulling free arm like this. That's a disaster. Something terrible is going to happen. You need to kind of lever yourself against something like this. If that's the right word, lever. Now we got to go around here and hit that spot with the soldering iron. I'm using my left hand. My soldering iron's not going to reach. I'm going to end up right in front of the camera here. Okay. Soldering iron won't reach from here. The plan has gone awry, so I got to switch hands. Oh, lost the hook. So luckily this radio is pretty stable up on its end like this, but if it were to fall over, I think that would involve more repair work. I don't want that to happen. Okay, so I'm going to get a grab on that. Okay, got it. I got it. Had it, lost it. Got it. Okay. Which one was it again? Okay, I can't do it like this. Arm's not in the right position. Do it like this. Okay, I think I can get some pull on it. These can be hard to pull out. Or maybe not. trying to make sure if the radio does tip, I've got my arms around it. Okay, something happened there. What happened? There it is. I don't know if you can see that in the camera. It's pulled straight up. Now I can either hook the other end or just try to get a grip on it. It's pretty tight in here though. Get a grip on it. I'm going to push it back over. Hook underneath. Okay, try to do the same maneuver. Desolder the other end. It's got to be right here. Again, I'm applying lots of pressure. You can see better this time. There it is. It's out. If I'm lucky, those holes are clear. I can put the new component right through, but often the solder blocks the holes, and as it did with basically every one of these orange ones I put in. And you have to position the hole, apply pressure, and then melt the solder and hope it pops through. There it is. 0.01. Lots of 0.01s in here. Okay, just wanted to show you what's involved in getting one of those done, well, it's half done. So here's another technique I'm going to use here on this capacitor, which I just removed. You cannot access the bottom of it under here properly. I might be able to get it out, but I have to solder underneath the switch here. I don't want to take the switch out. I don't want to do any of that kind of stuff. Putting a new one in would be even more difficult than getting this one out. So what I've done is I've cut it and left the lead sticking up. Not that this is going to make it super easy, but I'm going to try to solder the new capacitor to the old lead protruding up from the board here. Which, yeah, that should go okay. Do is I'll push the make sure this is correct. I already put one incorrect capacitor in and then realized that, hey, you're not paying attention to the sizes. I had to take it out and put in the correct one. So we'll put this one in on the one side first, and then it becomes stable and you can work with it. That's the theory. Soldering iron streamed out here. Okay, we're going right into this spot here. Hope it pops through. There it comes. Okay, so just kind of quickly tack that in. Now that the capacitor is stable, I can worry about the other end of it here. Okay, just wanted to show you there's different techniques to get around this kind of stuff. You don't have to always install things like through the board, and there's tricks. Okay, let's check a few of the capacitors I removed. Got one ready to go here. Okay, 50 volts. Does it close the eye? Oh, the eye popped right open. 150. Now, this ugly capacitor is actually not so bad. Okay, that's one. I don't like making the assumption that things are the way they are. I like some evidence here. So, okay, next capacitor. 50 volts. Good. Good at 150. I don't know how strong this is. This is a 500 volt capacitor. Let's give it one more height. Well, test just good. Now we don't know about the value. Well, I could test the value. 4,700 picofarads, but I would do it with a different device than this one. because it's much easier to check it with this guy here. $4,700 picofarads. Well, you can't read that, can you? It said no damaged, no unknown or a damaged part. Now, how can that be? Oh, maybe it's opening. Just put this over here for a sec. Maybe the eye is opening there because there's no real capacitance in here. Let's try it again. Okay, this time it says it's a capacitor, a 6,000 picofarad. And it's supposed to be 4,700. V loss 1.1. It's just not visible on the screen there, unfortunately. So capacitors, I find from my experience, when they read high, it usually means there's a leak in them. So, but they're not testing. They're not testing as if they're the worst they could be. They could be worse. Okay, time to test this guy out. The speakers are hooked up. Everything's plugged in. Switch is off. Power on for a quick test. Make sure the off switch is still working. Okay, here we go. Let me just change this light here. I'll just get rid of it. Broadcast. So I think I've done 4 capacitors since the last test. Okay, we're going to give it full juice here. Wow, we're getting much better volume. And we're working kind of down at the audio end of the radio, so I wouldn't expect the radio's reception to be any different. So when I move this funny control here, which only goes a quarter turn, it's kind of odd. When it's like this, both speakers balanced. And when it's like this, it's just the one on the left going. So I'm sure that's not how it's supposed to be. Now, see, I've tested the radio before in this angle, but not like this. So I don't think the radio is working any different. Let's see. And the light comes on. FM without an antenna. Let's throw the antenna on. Okay. Kind of, sort of, an antenna. Same sort of thing. More volume. There's definitely more volume. Great. Okay. Let me carry on and do a bunch more capacitors. Yeah, I was just going to get on with changing capacitors, but I've noticed something a little interesting here. I'll show you this. So, first of all, focus this set really close here. There's three of those capacitors right in a row. A little tight to work on. Okay, and another one here, but this is not what's interesting. What's interesting is back up here, this resistor, look at the way the lead is done there. The way it's kind of looped into a bit of a coil. Doesn't look that way in the camera. The camera's not doing it justice here. Yeah. But it's not just straight into the board. There's a loop. There, you can see it there now. Now, isn't that odd? Now, is that just because somebody was feeling fancy? Or is that some kind of a inductive thing happening there? I mean, that's not much of a coil. Who knows? But I don't want to disturb it. I think it would be a mistake. So, okay, five more capacitors. 1, 2, 3, 4, 5 more of those type I've been doing, and then we'll test it again. Okay, that takes care of the next 5. Now there's 2 back here. These 2. I'm going to leave those for now. These ones have a special shield on them. So there's the regular conductors at either end, and there's an extra conductor up here, which I'm sure is a shield. I don't have capacitors like that to put in there, and I would put an unshielded capacitor in there. Well, they have shields for a reason. They're probably in the audio. They're hooked up to the volume control or balance control. Strange quarter turn balance control. And I might end up with a humming machine that can't be resolved without that kind of capacitor in there. So guess what? We're ready for another test here. Fantastic. Okay, let me get everything hooked up on it. Hey, where'd it go? It's down here. Let me get everything hooked up on it, and we'll give it another test. Okay, time for another test here. Volume's down, switch is off, power's ready, dim bulbs ready, everybody ready. Broadcast. Wow, those lights went really quick. Those lights went really quick because I don't have half the tubes in. That's why. That's why that went so quick. Yes, that's my tube sensing system. Those lights over there. If there aren't tubes in the radio, the lights let you know. I'm pretty sure it wasn't going to work without these tubes. Okay, here we go. Attempt number 2. That's a little more normal. Lights on. Volume up. Full power.
Did you get them tonight? They gave them 7 Saturday, so I had to throw it out there.
Balance just is not doing the right thing.
He's not gonna get it tonight.
I've switched speakers the way I've connected them, so. I do have a stereo microphone in here, so you get some sense of stereo in the way the speakers are. But there's no stereo here, it's just left and right. So now this is what I was doing last time. That sounds balanced. That sounds all over on one side. I'm not sure what's going on here. Okay, quarter turn control. Okay, let's give FM a try. Oh, and I'm going to bring in the super FM antenna here. as much. Fantastic.
License number 10587. When you need mortgage money, you can count on Savers Mortgage to be the bank alternative.
Okay, so the purpose of the test is to make sure it's still working. Passed. Find out if there's any improvements. It might have been a little bit of an improvement there, but I'm not sure. And help decide what to do next. So the next capacitor I'm going to do is the infamous FM capacitor. The FM capacitor. So there's usually in these radios a particular capacitor that's found in the FM detector circuit. It's usually I think it's always an electrolytic, small electrolytic, somewhere in the area of like 10 microfarads. And this is very, very important for the FM detector. And that's probably it right there. Because I think this is the tube that's involved with detection, I think. And voila. Now, there's an electrolytic capacitor right there. Oh my gosh, that's my antenna falling behind everything. What's the value there? What is the value? Let's take a look. Five. That's almost certainly the what that capacitor is. It's in the FM detector. Let's take a look at the schematic for this. Okay, here we are at the end of the IF. Fancy stuff going on right here for the FM. This is the detector. And there it is, 5 microfarads right there. This guy plays a very important role and can really affect the quality of the FM sound. So we're going to change this one and see what happens. Okay, capacitor's out, and I was smart enough to mark the polarity on the radio. So here it is. Let's give it a test on this guy. I think you should be able to see it this time. Yeah. .278 picofarads. V loss nothing. You know what? I think maybe it's that's just a crazy reading. Let's just see if these are not, maybe they're not making good contact here. Try again. .265 picofarads. So this should be something like, I don't know, what would that be? 500,000 picofarad? I don't know, some big number. That's not good at all. By that test, anyway. Okay, so let's put in a new one. Let's see what we'll get. What kind of voltage? This only has to take just a few volts, I think. I used the 70 volt one here. Okay, let me find one, stick it in. We're going to try the radio again. Ready for another test. Now, in the meantime, I was just checking my email. I got an email from Charles relating a sad story of a radio very much like this, where the rectifier failed and took out the power transformer before action could be taken to prevent that. So that's kind of scary in a way. With this particular radio, I've noticed there's no rectifier tube, so I know there's some kind of diode or some kind of other rectifier in here. And I haven't even noticed where the power transformer is, which is not up on top here. It must be down underneath somewhere, and I just haven't noticed it. So Okay, so we're going to deal with that next. But first, let's take another risk. We'll operate this radio one more time here. Okay, so there's really a low risk of there being a defect with what I did. That would be so important as to cause those lights to come on constantly or something like that. Okay, but you know, I have a way of making mistakes. So volume down, power on full, all tubes are in. What do we got?
It's 5 o'clock. Coming up, I've got the reigning #1 tune on our top 20 countdown. It went 4 weeks straight.
Where is that pointer? There it is.
Giving a cross-check to Russia for its invasion of Ukraine.
I've only got one speaker going here.
Relationships in Russia, and the World Curling Federation has banned Russia and Belarus. Premier Doug Ford says many public health restrictions are lifted. It is not the Wild West. Vaccine certificate system, all remaining capacity limits for indoor public settings will come to an end tomorrow. But Ford says the pandemic is not over, though he did suggest mass mandates could end soon.
This is going to be the Wild West. Be cautious. We aren't through this yet. We see light at the end of it.
We see light.
The European recognition of Crimea as part of Russia could be one way.
Union. Canada is sending more weapons to Ukraine, including anti-tank.
What's going on there? Okay, so that definitely made a difference, but not on the volume. The volume is probably low because of the weak tube, which, guess what? The new tube is in the mail. It's on its way here already. Probably be here tomorrow or the next day, which is great. So now we want to deal with this issue about the selenium rectifier. Now, I've never ever run into trouble myself with a selenium rectifier, but I have heard horror stories. One of them is if you allow them to, they will burn and they produce a terrifying smoke that can literally stink you out of your house, and for a length of time. So I've heard that. I've heard they are not reliable. I have replaced them, quite a few in fact. I found them running hot, or hotter than I think they should be. So that's the story. Now, this particular radio must have a power transformer in it. I'm just unplugging things here. Let's tip it up and see what must be there. Oops, didn't unplug everything here. I don't know why only one speaker worked. Don't like that, but I'm not going to worry about it right now. I need my wooden block. There it is. Oh, there it is right there. That's a little hard to miss. Hidden kind of inside this area here. Of course, right near the power plug. Okay, now what about the rectifier? Often these rectifiers are mounted on the side or something to do with the chassis to help cool them. If it is the type that I suspect it is, use a little square block. So you see, fuse, big cable. I don't see it under here. Okay, it's usually, at least my experience is that they've been out on the side here. A lot of these radios, the power supply is actually quite separate from the main chassis too. It's kind of bolted on. Sometimes the power transformer and a few other parts are bolted separately into the cabinet. that's not it. Where have they hidden the rectifier? Well, it could be staring me in the face and I'm just not spotting it. So what I'm going to do is I'm going to do a little research, find out what it says in the schematic. Okay, nothing too surprising here. Here it is. This is probably a selenium block rectifier. May not be. Right on the high voltage wires of the power transformer, of course. Should be easy to find just by tracing wires from here. While I was looking at this, this caught my eye. A 1-inch length of number 32 copper wire. This is that fuse wire heater thing. I don't know what that is exactly. So maybe we'll spot this too. It's bound to be in close to, well, I could have got these lights ahead of this fuse thing. And X and Y are no doubt the heater lines. 7 volts light. Okay. Okay, let's hunt this guy down. We should be able to find it now. Okay, I'm going to tip this back up. Whoa. Okay, here's the transformer. Diagram here. Doesn't really help too much. Oh my gosh. Is this the rectifier right here? No. These are the wires coming out. Bottom. Going to power plug, of course. So working its way through the fuse. Where's this 1-inch wire thing? Okay, I don't know about that. It must be hanging out with the selenium rectifier. With the rectifier, we don't know that it's selenium just yet. Oh, there it is. There it is, right there. There it is. This piece right here. That is definitely a selenium rectifier. It's got some heat in it from just that little bit I operated it. Okay. Something interesting here that's worth noting. This is a common thing in radios like this. You know what, you're going to have to look with a close-up camera. That's what's going to be needed here. See those wires? See all that dirt collected on them? Kind of spread out. No dirt on these. Lots of dirt on these. These are high voltage wires. Going over, here's the rectifier. So the trick here, when you replace this, a couple things happen. One is you lose these terminals. So you have to. It's smart anyway to get a terminal strip, build your little full wave rectifier on it, and then somehow install it in the radio here and hook it up. So and then these are the leading leads here. Lots of slack. Where are they going? Wait a minute. The other way around. These are coming out of the transformer. I got it backwards. These are the leading leads here. Just the same. Lots of slack. They got lots and lots of wire here to work with. So this isn't going to be a problem. Okay. Mystery solved. Transformer found. Rectifier identified. Action must be taken. Thank you, Charles. Okay, I just looked up at the clock and surprised me, it's much later than I thought it was, so I'm done for the day. Tomorrow, first thing, will be the rectifier, dealing with that, and I'm not sure what else I can do with it at this point. So thanks a lot for watching, and stay tuned, or tune in tomorrow. Don't stay tuned, tune in tomorrow.